All right, so here's the first example by me explaining case 2. Okay, so I would not find the eigenvalue of this system. Okay, I would not do this in this video, but I will give you quickly the characteristic polynomial is lambda minus 2 square. So the repeated eigenvalue is 2 repeated twice. Okay, so just because we want to save time on this video, let's focus on finding eigenvectors because that's the new part, right? So well, we want to write a minus 2I matrix and we solve this equation, right? First let's find the natural eigenvector. Okay, so let's write a minus 2I matrix. That means you subtract 2 from the diagonal. 1 minus 2 is negative 1, negative 1, 1, 3 minus 2 is 1. So this is a minus 2I matrix and you have k1, k2. Here you want to solve for k1 and k2. So what do we get? So here let's multiply. So in 2 by 2 we don't generally use Gaussian elimination. So negative k1 minus k2 is equal to 0. k1 plus k2 is equal to 0. So you can use either equation because they are the same. So let's use the second equation. So what we really get is k1 is equal to negative k2. Okay, take k2 to the other side. So we can choose k2 to be 1, then k1 will become negative 1. See, we only get one eigenvector now. Okay, the eigenvalue is 2, but it's repeated. So this is capital K1. Capital K1. Okay, now we want to find the other eigenvector, or meaning the generalized eigenvector. So what do? You solve this new equation. What is it? A minus 2I still, but you want capital K2, so your right hand side is the eigenvector that you just found, K1. So A minus 2I matrix is still negative 1, negative 1, 1, 1. K2 is little k1, little k2. And the right hand side is k1 is negative 1, 1. That is what we just found here. So use the eigenvector that you just found, put it on the right hand side instead of 0. Okay. Okay, so now we can write two equations from here. Still we don't need Gaussian elimination really. So if you multiply, okay, so if you multiply, negative k1 minus k2 is equal to negative 1. Okay, k1 plus k2 is equal to 1. Okay, so these are the two equations I get. Now here also you can choose any equation, either equation, because they are the same. So let's choose the second equation because that does not have negatives. So k1 is 1 minus k2. Okay, now we have to make a choice for k2. So when you choose k2, you automatically get k1. So what would be a choice for k2? Well, you can choose k2 to be 0. Okay, now here's the thing. When you choose k2 to be 0, your k1 doesn't get 0. Okay, make sure you don't get the 0, 0 vector. Okay, because 0, 0 is not an eigenvector. So here when k2 is 0, k1 is 1. So fine. So this is capital K2 matrix. You could have choose k2 to be 1. Then 1 minus 1 is k1 is 0. That's also fine. Okay. So you can choose any number you like. But I choose it to be 0. Okay. So this is k2. This is the generalized eigenvector. So now let's summarize. Okay, and remember we write the general solution in a different way. So let's summarize. So the eigenvalue was 2. The natural eigenvector k1 is negative 1, 1. And the generalized eigenvector is 1, 0. Now let's construct the fundamental set of solution. The x1 is k1 times negative 1, 1 e to the 2t. x2 is k2 times 1, 0 e to the 2t plus t times negative 1, 1 e to the 2t. So this is x2, right? So finally we can write the general solution as a linear combination of both of them. c1 x1 negative 1, 1 e to the 2t plus c2 times the whole thing. 1, 0 e 2t plus t negative 1, 1 e to the 2t. So this is the general solution for the differential equation. Okay, so yeah, so that is how you work with when you have defective matrix. Okay, all right, thank you.